so that you can walk through it yourself. Here is what we have: a horizontal cylindrical pipe, 32 diameter, intersect the square pyramid K. Okay, K has to be defined at an angle of 30 degrees as shown. All right, we have 30 degrees as shown. Draw the elevation and the complete plan, the curve of intersection of the two views, the development of pipe F with RS as C. So we have pipe F. Pipe F is this. We know that it's a pipe because of this center line. And then we have K, which is this pyramid here. Let's complete the definition so that we know exactly what we're doing. So here we go. Now, how do we know what type of pyramid this is? We know these are two through lengths, one here and one on the side. And the question itself says it's a square pyramid. So we know it's a square pyramid. So the plan view is going to be a square pyramid. And the dimensions are not given, but the width of the entire pyramid from one end to another is given. So we can actually make do with that. So let's get ahead and draw construction lines straight up from the sides. Okay, we're trying to get the same distance down, and we're going to draw another vertical line from the center just to help us locate the middle. And with that, I believe we should be able to draw the pyramid. So let's look at another important parameter where we want to start our drawing from. So let's put this here. If we put this here, we have then what will it measure? Let me take a measuring tool to give me 39. So I'm also expecting 39 somewhere around here, since this is a square pyramid. Okay, and 39 also upwards, since it's a square pyramid. Okay, that's what we're going to do. You can take a circle. You can draw a circle just to cover that length, and then do that. This is the easiest way to actually go about this. So the next thing to do is to draw straight lines from here to each of the points shown. Okay, after this, I can actually take away this. It's no longer needed. So at the end of the day, I should have an angle of 45 degrees rather, from this point to this point, if it is properly constructed. Yeah, sure. That's it. So that's another way you can actually construct this. You can just use your set square, put it on one end, and then draw a straight line. I have the size of the pipe to be 32. That is shown here. So we can begin construction. We know that if we take this as our reference point, if we offset some distance 32, that will be 16 off this way. Take a radius of 16. I'm going to get our pipe just like it says on the other side. Yeah, good. So what's next now is to bring down that length. This very length down. That's probably the highest, the longest point there. Let's also check the middle and bring all those points down to the other side of the pyramid. So, too many lines here. We need to trim them up. Okay, that done. And on this pyramid too, to trim all of that off. The next thing to do is to draw the curve of intersection. All right, the curve of intersection going through the pyramid, like so. So we're going to draw our semicircle as usual. Since this is a pipe, it's a square, you have to draw a square. pyramid indicating that what it is. So we'll draw a semicircle and divide this semicircle into 4 equal parts. So dividing this into 4 equal parts. And using your compass, you know what to do. From this point to this point, create an arc. Now we'll create an arc. That'll be 2 points. Consider, and then we draw lines parallel to these points, like so, like this. So good. So these same lines must be represented in the plan view. So we'll do the same here in the plan view. Okay, we have our lines already, our imaginary cutting planes already cutting through the pipe and the cone. Okay, this depth you can draw yours as long as possible, but then that's the depth that I have chosen. And then we will do the same thing down on the plan. Same thing down on the plan right here. Okay, that's done. So now the next step is to trace all of those points on all of those cutting planes on the plan view as well. But those cutting planes cannot be traced on the plan view unless they are associated with the true lengths. So that's what we're going to do. We will draw straight lines from every point of entry of one side of the cone to the other and trace their corresponding lines on the plan. This is how it goes. Draw horizontal lines from 0 to intersect the other side of the pyramid. Same thing, this other side of the pyramid, just like we did in a cone. It's the same thing that happens here. As a matter of fact, the development of a cone and that of a pyramid carries the same process. It's called the development by radial method. So we're going to treat that. We've treated that already. So we'll look at how this is going to work out right here. So that's too much interference. So taking that short. So these are the cutting planes, points of entry of the cutting plane. So we'll trace that point on the plan view and see where it intersects these cutting planes that we also have. The same cutting plane on the pipe and the same cutting planes that we have in plan view. So let's do this quickly. I do not have to draw construction lines in me anymore. I can copy one of these construction lines and just drag them home. Here, 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 here. Those points, yeah, here on the line. But I'll terminate them on one known reference point, which is the horizontal line, because they pass through this XY plane. So we're terminating them here and redirecting this point at 45 degrees or parallel to the edges of the plane. This edge of the plane have to be represented all around here. This is what I mean. I'm taking this same line here, 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 here. So if you have your set square, just set it to intersect this. So it's going to cut this other line at this point. So now what do? Same thing. I repeat the same move. I move this, intersect here, intersect this point, intersect this point, intersect this point, and the last point intersects this point. Yeah, excellent. So I'm going to make this a little shortened so it doesn't interfere much with my lines right there. This one too, this way. So I'll trim this and continue the same thing until I had crossed all the cutting planes. So we're not going to terminate here. We're going to continue this exercise until we cut all the previous cutting planes. So I still have more cutting planes here to cut through. So I'll do the same thing all over again. Set square at 45 degrees. Lock it in with your t-square and continue to draw straight lines. All right. So they would intersect this other center line, so to speak. Yeah, so now we're done because we have cut through all of this point. You recall that this is more like what we did in the case of a cone. But in the case of a cone, let me show you quickly what we did. In the case of cone, because the base of a cone is circular, we had to go circles in circles. How to go in circles. These are the circles, right? How to go in circles from this center horizontal line, started going in circles until we cut all the cutting planes that are associated with that particular drawing. So now let's get back to pyramid. Same thing, same action, same action, same action. All right. So now we're going to trace all of these points from 0 to correct. So I'm taking a point 0 as my reference. There are two zeros here, the ends of zeros, and they should correspond exactly. That's what I'm looking for. They should correspond to the point here. So even at that, I still have missed it. 0. I can keep walking, forget about it. And then this point should also be exactly at 0. So I got this right. So move ahead. The next line defines from 0 after 0, you have 1. Yeah? So the intersect of 1 on 1 is here. So after 1, you have 2. The intersect of 2, line 2, is here. Now remember, we have 2 1s. So apart from this one, there's another one here cut. That should cut 1. That is not cutting that, so we have to extend these lines to actually get there. So I have my 1 here, I have my 1 here. I'm going to extend these lines to get there, extend these lines to get there, and now we can do this. Yeah, I have 1 here. Remember, this line is 2, very close to 1. So we have 1 here and we have 1 here. So we can continue with our work the way it is. Yep. So now we have all the points intersected at point 0, dovetailing with point 0. We have 1 intersecting 1 here, here, and here. I'm going to differentiate this so that we know exactly what we're doing. So this P naught right here. There's another P naught right here. Okay. We will move right to P1. After P naught, we have P1 intercepting this point. Actually, two points. There's another P1 from here, this line, intersecting 1 at this point. Put it up, yeah. Okay. From that point, there's another point here, 1. This line, 1. The P naught after P naught is 1. Intersecting 1 right here. I'm gonna put 1 here. If we look at this P naught, after P naught, this line P naught, there's a 1 here, intersecting 1.1 right here. So I'm put it here. So we have this 2 points, this 2 point P1, P naught, or P naught, and the next point to deal with is P2. So we have P2. After P1, I have P2. P2 will cut this line 2, this cutting plane 2, at this point. Exactly. Right here. So I'll trace the same point down here. P0, P1, P2 over here. have my P2 right here. So I have my P2 here. Now what? Since this is a pipe intersecting a pyramid, we expect that the line of intersection is going to be a curve. So we will draw our curve here and also find the intercept on this particular view. So that's what we're going to do. I'll also trace my points there. Let's do the same thing we did there. The easiest ones to identify is P naught. Because P naught is a starting point. P naught on P naught. There's another P naught down here, so I'll put P naught here. So that is done. We're done with that. So I'm locating P1. The intersection of P1 is the corresponding line going up and intersecting P1. So I'll trace P1 from here. I'll trace P1 from here. P1 from here. Which P1 am I tracing now? I have to be careful. This P0 from the bottom. So P1 from the bottom. P1 from the bottom is going to be this one here. This one here. Yeah. Okay. Yeah. This P1. Remember, what you're tracing is not the inclined plane. This one. Yes. I also make that mistake sometimes. So I'll trace the inclined plane again. But I'm tracing this P1 now. So this is the P1 inclined. I'll trace that P1 inclined. This one, the intercept is here. I'll move this line straight to P1 and pitch my tent here. Okay. Now P2 is easy to locate because that's probably the only intercept. This is P2, very close to P1. Very, very close to P1, yeah. I press P2 and pitch my tent right here. Okay. Good. So I have this point P0, P1, P2, P3, so back to P0. So we can trace our curve now. Remember I told you it's going to be a curve? P1 is here. I'm careful with that line. And then P2 is here. P1 is here. And then we're back P0. Excellent. So this is the curve of intersection. This is what is regarded as the curve of intersection on this elevation. So we will do the same thing on the plan view. Whatever you do in the plan view, do in the elevation. Whatever you do in the elevation view, please do the same thing on the plan view, unless if it's not too necessary, as is the case of a cylinder. We intersect P1 from P0. The other point is P2. The next point is coming back to P1 and then back to P0. And then we're going to P1 and then to P2 to P1 and then all back to P0. Right. This curve too should be given some respect. So we use a thicker line to represent that. Yeah, same color. We'll represent that. So this is what they expect us to do. Looking beautiful there. Right. Another thing we need to look out for is to actually simulate what this pipe is going to look like in the plan view, this part. How is it going to appear in the plan view? We're expecting it to have a point here, point here, point here, point here to form an ellipse. Let's see what we do that. So to form an ellipse, we have to extend all the lines again. on these lines, every point in the front view will have to be represented on the plan. So we have here point 1 and another point here, point 1. That corresponding point, we would have to look at it. In the plan view. Let's look at it in the plan view. Beautifully done. So now we can trace the curve. We can start from anywhere, start from 0 to 1 to 2 to 1 to 0 to 1 to 2 to 1 and back to 0. So that curve that you see there, that pipe that you see at the top inclined, would appear like this. Yeah, so we have everything represented already. We'll just highlight that. And the next challenge, we have the curve of intersection here. We have the curve of intersection here. We have the cone, everything represented in the plan and in the front view. The next challenge is to draw the development of pipe F. This development of pipe F, we're going to take distances around here and represent them in this manner. And yeah, before we do that, let's look at what details we may want to consider in this curve of intersection. The only part that will be solid here is from P2, the top that we can see. This top P1, P0, and then back to P1 and then back to P2. The other P1, P0, and back to P1 to touch P2 will be hidden lines. In fact, this part of the square cylinder would also be all hidden lines. So let's do that. Okay. The dotted lines, the hidden lines have been represented already. I can only make you see that if I preview this. Let me do that. Let me show you the preview. Yeah. So here's the preview of that baseline that you're looking at. This is now hidden line, and this part is also hidden. So the finishing touches, this side are supposed to be solid line. This one, solid lines all through. And this is what you have as your curve of intersection, all the points highlighted. And yeah, so the top view of that cone is shown here as an ellipse. So the next challenge now is the development of this pipe F. To develop this pipe F, what we need to do is to tear this place open, which is referred to in the question as the seam. Here, the development of pipe F with RS as the seam. So I'm going to take RS as seam and then tear it up here. Open it up this way. Open it up this way. And the divisions that I have on it is still going to be represented here, where we have 0, 1, 2, 3, 4, all alternating on this part. And each of those points will be represented on the development, P1, P2, P0, and all of that. So let's do that. Let's get at it and you see what. All right, if we tear this part open from this point to this point, how long is going to be that part? It is going to be the circumference of this circle that is here, and the circumference of this circle has a diameter of 32. So 2 pi r will be the circumference of the circle, or pi d to give you 101. So the length, tearing it open from RS opened this way to give you a rectangle, the length will be 101. All right, and then the next thing to do is to actually represent all of this point was 0, 1, 2, 3, and back to 0 on all of this point, and that's what we're going to do. So the approximate way to do this is to take distances from each of the divisions from here to 1. This is okay. This is 18.8. Remember, it's just an approximate distance because what you're actually taking is the chord, not the arc. So I'll take 12 millimeters, that's 1.2 centimeters. I'll create an arc here. Create an arc like so. I'll create an arc like that, or take my ruler and offset the same distances across board. Take my ruler and offset these distances. Take this one, 12, right there. Take this one, another 12, another 12, another 12, another 12, another 12, another 12, and another 12. This is the reason why you cannot be this accurate, because see, there's a gap here. But we can make do with that to delete this and then walk it through. It's not a crime. What they want to see is your job well done, right? Alternatively, you could divide this line into 12 equal parts by doing this and then dividing this into 8 equal parts. Into 8 equal parts. You draw the 8th line, 8 points to that point. Right there. I want you to see what I'm doing. And then note the point on all equal divisions. Right here, right there, right here. Have another point here, and the last point right here. So you can actually trim this out. So nice and cool. So it removes all the errors that we initially have, and you can actually work with this with the dimension that you have 101, right? Just take your ruler, rule it, t-square, have it here, and have it here, and have it here, and have it here. Okay, good. Have it all. Next is to label them accordingly and trace the curve of intersection. Okay, now we have them labeled. The next challenge is to determine how long this pipe or how wide this pipe is going to be from this point to this point. The highest point on the pipe is actually 2. So we are going to measure that length and make sure it corresponds with what we have. So we have from here to position 2 is approximately 58. I see 57. Let's do this. Here is it. Yeah, right here. Pitch it here, and it's 57. So I'll take that same dimension and make sure that the height of this is also the same, 57. So see that? So that's the highest point. Now what? What's next? What's next is that highest point, you have to offset that point to this point. Coincidentally, let's see what happens. If I pick this line here, because it's parallel, that's what you're going to be using anyway. It's parallel to this. It's going to pass through the same point as what we have up there. I put it here. I put it on 2. Yeah. Okay, my 2 is right here. Okay. I'm going to have these 2 lines. See, they intercept at the same point. So yeah, they intercept at the same point, or the variation is not that too much, so to speak. Yeah. So the intercept P1 at the top intercepts here, and I have P1 below intercepting. No, intercept isn't here. It's supposed to be right here. trace it back. Okay, they are not in the same line. I just checked. They're not in the same line. So I have P1 here. I'll have to take the same line parallel and find its intersection on the bottom P1, which is here. I'm going to have 3 points now. I have P0, P1, P2, and then back to P1, having different addresses, 1, 2, 3 lines. So I'll take all of these 3 lines and position them on that point. If you're using a compass, it's actually easy. You just take distance from this side, from this side to point P1. That's what we're going to do. So I'll show you how to do that shortly. We need to address this. P0 has the same address, so we're going to use what's the height of this again? 38. We're going to use 38 to find P0 on this line. So simply do this. Get 38. All right, this is our P0. You can write P0 there. Identify P0. Okay, we have our P0. So from P0 which will be a reference point. Take your compass, place it on that point P1, and trace the P1 that you're looking for. If I do that, I'm going to get, since this is a straight line and parallel, I'm going to get P1 right here. 13. I have 13. So I have 13. This line will go 13. All right, this is P1. There are 2 P1s, so I have to trace this P1 again. So take my measurement from P1, the through length P1 going down deep there. I have 10. I'm going to take 10. I'm going to dive 10 in. I have my P1 now. Yeah. Okay. So P2 is this. So we have 2 P1s. So we're done. We would simply draw the points and join them. Okay. I have drawn indicated all the points. Right. I have my P0. The P0 here, this particular one, and there are 2. So we can trace that, it's easy. There's a P0 at the bottom. There's already P0, which is below the P0 that's at the top, which is this P1 rather. That's at the top, and then we have this P0, P1 below. So P2, which is the highest point, stays high. So now let's start tracing the curve from the scene S. Okay. The development of that pipe is going to be from starting from the bottom. We're starting from here, from the bottom. So we're going to go from bottom to the top and then back to the other part. The bottom to P1. Remember, we are drawing with respect to these numbers now. This is 1. I'll go 1. And then to the highest point. Look at the right side of my screen. You see P0 here. And then it dives back to P1. P1 is not this P1. It's not the bottom P1 now. It's the top P1. Yeah. And then it goes to P0. Back to 0. Then from P0, again, it takes another dive. It will repeat the same circle. There. Touch the top. This time around the top. The highest point gets to the bottom to get to P1 and get back to the bottom. Right. Here is a curve that we've been asked to draw, and this is what the development is going to look like. So if I solidify this pipe, I'll have this, and I'll have my lines drawn following this path from here to here. I'll have this closed, and I'll have my line traced back to this point. So this is the cover of this is the development that we were expected to draw. So let's review this and see what it looks like. Yeah, right here. So we have it here. I zoom in. This is the development of what you're going to see. This is the development of pipe F, and this is what you're going to see. All right, it's going to go in this fashion. And then back to the bottom. If you close this pipe back, you're going to get exactly what you're seeing here. So this is what we've been asked to do, to draw the curve of intersection, and whatever appears as curve of intersection in the front view, it will also appear that way in the plan view. And the pipe, if it's inclined, that inclined pipe would appear as an ellipse. It will appear as an ellipse here. And if you're developing this, you tear it open, and then when you tear it open, you identify all the points that needed to be identified with respect to the circumference of the pipe in consideration. You will have this as your development. So that is what we have for today. So thank you so much for watching. I'll clean this up. There's a lot of construction lines around. Clean it up and print the manuscript in the description below. You can find it, download it in the description below, and use it for practice. Thank you.